Okay, great. So my name is Jess Bradford. I'm from the Future Students team at the Faculty of Engineering and IT. So I can help you with any admissions-based questions that you might have after the session. In a moment, I'll hand you over to Professor Lee Johnson, who is going to talk to you about what biomedical engineering is and also talk about our Master of Biomedical Engineering program here at the university. Before we begin, I would like to acknowledge the traditional custodians of the land on which we're meeting today, the Wurundjeri people of the Kulin Nation, and pay my respects to their elders past, present and emerging. And I extend that respect to any Aboriginal or Torres Strait Islander people here today. Lee, if you wouldn't mind flicking to the next slide, I just want to talk about the Engine IT community before Lee starts her presentation. So if you're not part of the engineering and IT community already, this is a club that's been set up by the faculty for current undergraduate students who are interested in becoming an engineer or an IT professional. So if you do join, you'll receive access to personalized consultations with our team and the latest news about events like this one. And we also run social events like barbecues and opportunities to network with industry and your fellow students on the same pathway. So if you haven't already joined, I encourage everyone to do so. It's completely free and let your friends know about it too. Anyway, that's enough from me. I'll hand over to Professor Lee Johnson now.
Excellent. Thank you, Jess, and welcome everybody to today's session, the deep dive into the biomedical engineering. So I'm the current head of department of biomedical engineering. I've been in this position for a long 6 months. No, so it hasn't been very long at all. And this is the first presentation I'm giving as head of department actually to undergrad students. But of course, I have done a lot of lecturing, and so maybe know some of you, I'm not sure. But anyway, welcome. Thanks for joining us today. And let me make a start. So you heard about the engineering and IT community, but let me direct you specifically to the Biomedical Engineering Student Society, or Melbourne Uni Biomedical Engineering Student Society, which has the acronym of MUBES. And this is the committee for this year. They are a fantastically committed bunch of students, largely in the Master of Biomedical Engineering degree. And I would encourage you, just Google them, you will find the links to them immediately. If you are interested in getting involved, and you can certainly do that as an undergrad student, you do not have to be a master's student to be involved in this student society. They run all sorts of events throughout the year, from social to industry networking nights, to Q&A sessions with academics about our courses, etc. So great club. Highly recommend that you make contact with them if you're interested. Okay, so what is biomedical engineering? And I think this is something that students aren't aware of the breadth of what biomedical engineering might actually entail, because we have this idea in our heads perhaps that biomedical engineering is machines that go beep in hospitals, right? We see this on TV all the time. Somebody's, in the ICU or in the emergency room, and there's a machine next to it just going beep, beep, beep. A biomedical engineer is more than just the person in the hospital that fixes those machines when they stop going beep. Okay. As I'm going to tell you, that is an actual area of biomedical engineering called clinical engineering, but you'll see that there's so much more than that as well. Okay, so in general, as I've written on the slide there, what is biomedical engineering? It's the engineering discipline that looks at meeting health challenges of the future. Okay, and what does that mean? So you can rest assured that there is biomedical engineering involved in every single health aspect of healthcare. All right. So how do we ensure that somebody has the correct diagnosis? Sure, a clinician is making a diagnosis, but how are they making those diagnoses? They're making them on the basis of equipment or devices or methods that engineers have developed. So as I've written there, design a new medical device, that's part of it, but also in general, it's solving the clinical problems to help patients, right? So biology, health, maths, they're the basics of biomedical engineering. Another way of looking at that is on a fabulous Venn diagram. So it's the intersection here between medicine, science, and engineering, and biomedical engineering sits in the middle of all of that. if we're looking at career outcomes for biomedical engineers, it is, as I mentioned, it's not just hospitals. They're not just hospitals, they're the industries that you can get involved in, but there's even biomedical engineers working in petrochemical industry, believe it or not. Okay, so anywhere from biotech, pharmaceuticals, project management and consultancies, they all hire biomedical engineers. And listed in the middle here is just a brief list of some of the companies and research institutes, and you can see the Royal Children's Hospital, that have employed our graduates in the last couple of years. But this is not an exhaustive list, this is just a select list. Very diverse group of companies there. So GE, a global multinational company, Accenture is another very large company, down to Bionics Institute, which is over in East Melbourne. It's a very small research institute. Okay, so it's a wide range of roles that people can come out with. And what are those roles? Anywhere from doing R&D type work with something like the Bionics Institute to being a field service technician or a clinical engineer or a hardware engineer. So I hope I'm getting the point across that it isn't just one role as a biomedical engineer. So let's get more into the types of biomedical engineering, and I'm going to give you something of a cook's tour as to what biomedical engineering can entail. All of these, biomechanics, tissue engineering, etc., down to more esoteric things like biosignals, and what does that actually mean? This image on the right, this is Peter Lee in the middle. He's one of our biomechanics professors in the department, and he has for a long time worked on prosthetic devices for low-cost prosthetic devices, for example, when people have lost lower limb. Okay, now it sounds like, and you can see what the lower limb replacement there looks fairly low tech. This isn't an exoskeleton, for example, but biomedical engineers are not just about making things high tech, they're also looking for low cost solutions that can be implemented widely around the world. Okay, so there is a very large overlap between humanitarian efforts and biomedical engineering as well. So let's start with the biosignals area. And am I being completely biased in starting with biosignals? Potentially, because that's my background. So here we see, and I could, if I was running this as an interactive lecture, I'd say, well, what are we looking at here? And you can take a guess, but this is actually an EEG, so electroencephalography cap. So those electrodes are being sensitive to the neural activity in the brain. And the syringe there, I'll reassure you that this is not a syringe that's injecting into the head. That's actually just got some paste in it to make sure that the electrodes stick properly to the head. And so the recording of these neural signals is all, can be encapsulated in a term called biosignals. Now, the two people in this that are administering this experiment here, this is Professor Mark Cook, who's a neurologist that our department works closely with, and Dean Freestone, who is a graduate of our PhD program. And just recently, they had created a company called SEER Medical, and you may not be able to pick them out, but this is at the governor's award ceremony. They won the Startup of the Year for their SEER Medical, and I thought that it might be interesting to see them. This is them a while ago, and this is them in more recent times, a few years after having a very successful startup that's arisen out of work that came out of the department. All right, let's move on from biosignals to biomechanics. And so here we have an image of a skeleton running across the screen. Okay, so obviously it's not just a skeleton. What's happened here is that somebody has come into a gait analysis lab and had markers placed on their bodies. And then there are X-ray systems that run alongside a person while they're moving. Okay, so in this case, they're running. And the X-rays are sensitive to bone and to these markers, which you can see on the right-hand side that are placed on the human. And what the biomechanics people do is they work out what the aspects of somebody's running movement is. So you can imagine that biomechanics has a lot of applications in sports, but also in rehabilitation and in helping the elderly, etc. And I've got some more slides on that coming up. All right, to tissue engineering. So again, if we think about what our popular culture thinks of tissue engineering, it is putting somebody's growing a replacement ear for somebody who loses one in an accident, or being able to transplant an artificial heart, etc. This is all part of the area of tissue engineering, and it is growing so rapidly at such a large pace, it's hard to keep track of exactly what the field is up to. The images on the left and in the center here show this is very much a lab-based career. So it is, if you like, the biocellular side of biomedical engineering. And a lot of what they're doing is about tissue scaffolds. And so here's a rendered image of a tissue scaffold on the right-hand side. Clinical engineering, and it's an old image, but I've left it in there because this is Emmanuel Koumandouros, who was a clinical engineer that worked with the department for many years, maker of life-saving devices. So indeed, the machines that go beep in the hospital, for example, humidity cribs for preterm birth babies, all of this has been designed by biomedical engineers and is kept in operation by biomedical engineers. And so if that kind of hardware side of things really excites you, and coupling that with health, then clinical engineering is an amazing space to be in. Okay, so rehabilitation engineering, and I mentioned that this was part of biomechanics. So the video here is from the gait analysis lab at the Children's Hospital. And this is a boy with cerebral palsy, and he is being tracked as he walks in this gait analysis lab. I don't know if you can see the cameras at the side, but he has these markers on his legs and is undergoing a video analysis, so not X-ray in this case, but a video analysis of his gait in order that the clinicians and researchers there can actually analyze his walking pattern to be able to help him with exercises and see the effects of their therapy. So on the right-hand side is an image of one of our graduates, Melissa Louie, and she not only did her biomedicine undergrad with us, but also a Master of Engineering. She then went off and got a job in the gait analysis lab as a graduate engineer. And a few years after that, realized that she really wanted a more deep understanding of that which she was working on. And so she came and did a PhD in collaboration between the Children's Hospital and our department, and actually now works as a researcher at the Bionics Institute studying Parkinson's disease. And there is all sorts of overlap between the biomechanics that she studied with cerebral palsy and other such diseases, and Parkinson's disease, which is a neurodegenerative disease that some people are afflicted by. So that type of career is not uncommon for people that study biomedical engineering. Right, medical bionics is another really exciting area of biomedical engineering, and this is an image that we've had for a while since Bionic Vision Australia started. So Bionic Vision Australia was a University of Melbourne based research organisation, and the aims of it were to develop a visual prosthesis. What do we mean by that? How do we restore sight to blind people? And there are various ways that this can be done, and different groups around the world have approached things differently. But at the University of Melbourne and our partners around Australia looked at, actually built retinal implants. Okay, so implants that go at the back of the eye in order to receive the light, do the processing, and then directly communicate with the brain via the optic nerve back to the visual cortex at the back of the brain. And so in the next slide here, this is the spin-out company, BVT, Bionic Vision Technologies, that came out of Bionic Vision Australia, the research group. And as it says, they're restoring functional vision for the blind, and it's quite amazing what they're up to now. So let's switch to a different type of vision. This is medical imaging, and this is actually the area that I would love to stay and talk to you about because it's my particular specialty. So this here is an MRI scanner. That is a massive superconducting magnet. It sits on the campus of the University of Melbourne, and I teach a subject called medical imaging in the Master of biomedical engineering. Very popular subject because we get to look at big pieces of equipment like MRI scanners, CT scanners, PET scanners, ultrasound, handheld ultrasound systems, etc. So why is medical imaging such a big part of biomedical engineering? Because pretty much nowadays, any type of disease condition, any type of, you go into an ER, what happens? You get some form of imaging. If you're pregnant, you've got ultrasound imaging. If you have had a stroke, you will go and have a CT. If you have need a knee reconstruction, you will have an MRI. Okay, so the way that this technology works is utterly amazing. It still boggles my brain, many years after getting into this field, that we can take non-invasively. Okay, so we're not harming anybody. We can take non-invasive images of people and see the three-dimensional structure inside their body. And so here, a rendering like this of what the brain looks like and the arteries that come up into the brain, the carotid arteries, etc., and regions of the brain, all of this rendering is done by having had high-resolution MRI scans first. And down the bottom, this is an example that comes off our, again, we have not just an MRI scanner on campus, but a PET scanner as well, PET being positron emission tomography. So it's a radioactive tracer that's injected into somebody's body. It's uptake preferentially, and you can see that this pattern of uptake between a group of normal or controls is very different to how people with Alzheimer's, the uptake of that radio tracer. And so we study various types of imaging, various types of PET imaging, in order to be able to contribute to studies on dementia, Parkinson's, Huntington's, multiple sclerosis, Alzheimer's, etc. And on the right here, I'll just draw you to another pretty picture. So the second author on this, Andrew Zaleski, is one of our academics in the Department of Biomedical Engineering as well. Fundamentals of brain network analysis. Okay, so when somebody has schizophrenia, how is the network of neurons in their brain behaving differently to those of us that are quote unquote normal? That's the kind of work that you can do if you're interested in medical imaging. All right, moving on to another type of biomedical engineering. This is implant development. So again, if I was in a lecture, I'd say, okay, what are we looking at here on the left-hand side? But I'll just tell you, this is a hip implant, so a hip replacement. And perhaps you've heard, or maybe your grandparents or someone have had a hip replacement. This is what an X-ray image with some rendering of it actually looks like. And here on the right-hand side, you can actually see a joint replacement working. So, and again, look, hey, that's using imaging. But our biomechanics group, led by Professor Peter Lee and Associate Professor David Ackland, work very heavily in this space of implants. And I have another slide to show you on this. And there are many subjects that you can take and research project opportunities, industry project opportunities in this implant development space. And in fact, here is the next slide. Okay, so one of the projects that our department have been involved in is an artificial jaw replacement. Okay, so it's I think that this was titanium, but I'm not entirely sure. But when somebody needs their bone, for whatever reason, maybe has been affected by cancer or by a developmental defect, now we have the technology to be able to design personalized implants and then surgically replace the affected part. And you can see here, it wasn't just a jaw replacement. The TMJ joint there, it was also, I don't know if you can see some metal at the front there, but this person was actually given more of a chin than they had before, and it completely altered the look of their face and has given them a whole new lease on life. So really, really impactful work here. And there are various companies around, such as companies like Anatomics, that are hiring graduate engineers to work on exactly this type of problem. All right, medical device design. So this is what a lot of people want to get into, is the really cool electrical kind of miniature devices and what we can do with them. So I'm not sure if you've heard of the Stentrode, but the Stentrode is an amazing developing success story that's come out of the University of Melbourne. The Stentrode, this is a picture of the Stentrode. You can see it's very small, about the size of a match, and this is wire with a catheter. Okay, so it's a catheter of the type, or stent, that you would insert into somebody's brain. And so when we want to be able, so say somebody is paraplegic, quadriplegic, and you want to be able to communicate with them and give them back some movement. All right, so this is the aim. What you can do is, if you want to be able to stimulate into their motor cortex, which is kind of midway through your brain up the top, how do you reach that motor cortex? Well, one way is to do a horribly invasive surgery, okay, and actually cut the skull and implant through the skull, which, of course, as you can imagine, has all sorts of side effects associated with it. So the Stentrode project and the spin-off company associated with this called Synchron, what their idea is to implant through the vascular system the electrodes that can then interface with the neural tissue. Okay, so a stent that goes up into the brain and stays there, grows into the tissue, and it can then both record, so receive information, and transmit information directly to the neurons. So that is, that is very, very much 21st century technology. Well, yes, I'm getting my centuries mixed up. It is very cutting edge and amazing work that they're doing. So moving to something completely different, bioinformatics. So what is bioinformatics? The study of genome data, think of it that way. And while we don't, we do teach subjects, but they tend to be through our computing and information systems department, who have a very, very core team of bioinformaticians and the subjects that they teach there. But I will come to that in a little while in the talk to say, if you're interested in bioinformatics, this is the kind of subjects to take. Systems biology is a little bit like bioinformatics, but the engineers that work in systems biology are essentially looking at a model of a cell, okay, and so you've got ion channels on the edges, etc. All of the various parts, the mitochondria, etc., that are internal to the cell. They're looking at that cell and making mathematical models of how all the different parts of the cell interact and how they interact with the environment. So computational biology, systems biology is on the rise, particularly as computers get bigger and faster, and our ability to make predictions of what happens in biology is driven now by computational biology. All right, and I think this might be the last of these, Cook's tour through biomedical engineering, the area of nanotechnology. So what's nanotechnology? Think of it, anything that's being done on a nanoscale. And it might be implanting very small nanoparticles into a cell to make it behave in a certain way. It might be using nanoparticles to be contrast agents to be able to see better on an imaging technology. But nanotechnology is certainly a very big area that biomedical engineers can get into. All right. It is fair to say that this brief tour that I've taken you on is not complete. There's many others, and the important point is that some of them have not even been thought of yet. This is a growth area, okay? It is not, in electrical engineering, come and study Ohm's law. We know about Ohm's law. I'm being unfair there. I'm an electrical engineer originally, so I can pick on them a bit, but biomedical engineering is at the forefront of technology. Okay, it is an absolutely wonderful area to work in. So let's talk a little bit about being in our master's program and what that means and what opportunities there are and what the employability is like. So there is the opportunity to take an internship for credit. Okay, so there's a 25-point internship subject, and if you can't find 25 points, we can actually find a way to make it a 12.5-point subject as well. We want our students to go out into industry and experience working in a company. Okay, or if you want to try out research, there is ways to make that happen in an independent research lab as well. So we have really good connections with industry, and it's not just through our internships, but also with our capstone projects, which are the final year projects that all engineering students need to do. We also have our students take, and this is common across all the disciplines, a subject, more of a communications type subject called Creating Innovative Engineering, and there's a couple of different versions of that. We have something called Biodesign Innovation, which I'll talk a bit more about in a minute, and things like the STEM mentoring program. that our students can become involved in. There are all sorts of career building workshops, employability workshops, some of which are run by the staff and some of which are run by clubs such as MUBES in conjunction with the staff. And yes, and just a note there, all sorts of clubs and societies within engineering that I would heartily encourage you to be involved in. There is, I'm just looking for it, it's not listed here. There is an engineering music society, which you may not know from the outset, but they've got many different groups and they have been running many years and do some really great things. So, and just at the end of this slide here, the Endeavour exhibition, what that is all of these capstone projects, which are our final year projects from biomedical engineering, electrical, mechanical, etc., all present their work to a public audience, meaning that one day per year at the end of October, so at the end of week 12 of semester 2, and now we've started doing it in mid-year as well. The students get a chance to stand up in front of a booth virtually over the last couple of years, unfortunately, but hopefully getting more and more back to in-person now, to present their work and to showcase that not just to industry people who come along, but also to school children as well. So that's an exciting part of our year each year, is the Endeavour exhibition. I'll just draw your attention on the right here before I talk about biodesign innovation. This is a good lead in. So this is Xing, and Xing was a graduate from 2017 from memory, but he did the Master of Engineering Biomedical, and he is the COO of a company called Navi Medical Technologies that was a startup that arose out of their final year project through biodesign innovation. And so they're going absolute fantastically now, and there are a few such companies around, and we're very happy and proud to be involved in their development. So what is this biodesign innovation subject? So the idea is that each year some of the biomedical engineering students get the opportunity, rather than doing a capstone project, and it also takes a couple of approved electives, it's a 50-point subject in which the biomedical engineering students are put into groups with Master of Business Administration students, so MBA students from the business side. And they work in these small groups and they find a clinical problem that needs solving by going and talking to lots of clinicians, nurses, physios, anywhere in the healthcare system. What is a clinical problem that needs solving? And proposing a medical device solution to that, and prototyping that medical device, and also doing a business plan of what would it take to commercialize this technology. And each year there are a couple of groups that actually spin off their company. So the Xing from the previous slide, who started with some of his group members, Navi Medical Technologies, this is a list here off the Navi website of all of the different places that they have received funding from thus far. So on the left here, this is Elise Sutherland, who is the CEO of Stelect. And as you can perhaps just see there, balloon catheter with spatial sensors. So this is a technology to aid clinicians in placement of catheters. And they won the MedTech's Got Talent competition recently. So this is the kind of example of if you have that kind of entrepreneurial bent and you're really interested in making devices and getting out there into industry, what better way of doing it than through developing your own company? So something about employment outcomes. And at this point, I think I'm going to start to talk through these slides, not just me, but with Jess as well. So Jess, if there's anything that you think that I'm missing here, please chime in. But certainly biomedical engineering is continuing to grow, all right? And we are going to need more and more biomedical engineers to come up with innovative solutions to all of the world's health problems. You can get involved in all sorts of programs while you're doing your engineering study at Melbourne, such as the Melbourne Accelerator program. Again, if you have this kind of entrepreneurial interest, you can also, as I will mention in a bit, you can also study a biomedical engineering with business degree if you're interested more on that industrial side. So ranked number 7 in the world, apparently, for graduate employability. 93% of our graduates employed 4 months after graduation, which is a very high statistic. 250 Australian and international organisations that actively recruit on campus. So the university is a really great place to be studying engineering. All right, so how do you study biomedical engineering? You can come to it via a bunch of different ways. And so if you are a current University of Melbourne student, you can come to a Master of Biomedical Engineering with or without the business specialisation, either via a Bachelor of Biomedicine, a Bachelor of Science, or perhaps the Bachelor of Commerce. This one on the right-hand side is definitely less common. We have roughly half of our students come from the Bachelor of Biomed and the Bachelor of Science. And you'll see that in both cases, they're studying the Bioengineering Systems major. So that Bioengineering Systems major is the same, regardless of whether you take it through the science degree or the biomedicine degree. Then you come into your master's degree. And if you've come through one of these pathway degrees, then it will be a 2-year program rather than a 3-year program. And then you exit off into the wide world of your career with a degree that's accredited not just in Australia, but also has international accreditations to allow you to work widely. Okay, so if you were, and I've just chosen this as an example, if you were a Bachelor of Biomedicine student studying the Bioengineering Systems degree, what would it look like? So in your first year, you would be studying subjects that you have to, that are, for example, you have to take chemistry for biomedicine, discovering biomedicine, etc. You'll see that you take Calc 2 and linear algebra. You've got some your breadth subjects you can use to do some of the engineering subjects, the first year subjects, engineering, technology and society, and modeling design. And then in second year, this is where we start to get the engineering, the biomedical engineering specific subjects. So applied computation, eng maths. And then in the third year, these are the 4 subjects that define the major, the bioengineering systems major, which is circuits and systems. So that's signal processing and circuit theory. Mechanics, that's like an introductory biomechanics, an introductory biomaterials course, and biosystems design, which is workshop based, and that's where you actually start to make and understand devices with a very hands-on aspect to it. Not to say that there isn't hands-on aspects to all of this and all of the engineering subjects, but biosystems design, rather than having a lot of lectures and some workshops, it flips it and has lots of workshops and a couple of lectures. So that's what it would look like if you're coming through the biomedicine degree. In the science degree, it's the same coloured subjects in here, and these ones on the left-hand side, you've just got a bit more flexibility with what you're studying. In the Master of Biomedical Engineering, and sometimes in this slides, you've seen me refer to it as the Master of Engineering bracket Biomedical. That's what it was called up until very recently, and we've now changed it, so it's much easier. It's the Master of Biomedical Engineering. So if you have come through a pathway degree, then it's a 2-year program, and this is an indicative course plan. So everything that's in grey are subjects that you have to study. Okay, so you don't just forget biomechanics once you've done the 3rd year subject. You're now doing a master's level biomechanics. You're doing a master's level biosignal processing, biofluids. You need to learn all about management and regulations. It's very important that we understand how the Therapeutic Goods Administration, how in the US it's the FDA, how do you get a device to market? All right, that's a very, very core part of being a biomedical engineer. And this is the capstone project that I was mentioning that goes across a full year. And all of these blue subjects here are elective subjects. So the bioengineering electives, of which there are 5 in this core degree, come from a list that I'm about to show you. And these approved electives are ones that you can essentially take subjects that you want, so long as you satisfy the prerequisites for it. So some people will be very keen on going and doing a 9-level introductory Japanese subject that they found. Other people say, actually, I want some technical depth. I'm going to go and learn some more about artificial intelligence. Some people improve their programming skills. Some people do a music subject, right? So we deliberately keep that breadth in our master's degree. These approved electives are also where you would insert an internship in your degree. And for those people that are doing biodesign innovation, so this much more entrepreneurial work with the the MBA students, we would take up this capstone project plus 2 of these other subjects. Okay, so coming back to exactly what you'd study, bioengineering electives, what are they? So here is the current list from the handbook as to what our bioengineering electives are, and you get to choose 5 of these. This one at the top just happens to be my favorite, the one that I teach, but you can see it covers a whole range of different topics, such as tissue engineering and stem cells, down to what I was mentioning, these comp subjects. So they're computing and information system subjects, but they're our bioinformatics subjects. Okay, we run systems and synthetic biology, various biomechanics, etc. And also our chemical engineering colleagues run this pharmaceutical and biochemical production subjects. So there is something in that for everyone. And what you can be assured is that you have to take enough of these that you get depth in a whole range of areas. We don't just make you do biomechanics, and that's all in your degree, okay? So that kind of separates the University of Melbourne master's degree from some others that are around Australia, in that we have that core expertise across the breadth of biomedical engineering. All right, the with business option, so Master of Biomedical Engineering with business. So this is something that has been developed in conjunction with the Melbourne Business School, and essentially you replace some of the other subjects with these management contractual subjects, etc. So again, if you really do see yourself in business doing more of the project management and businessy side of things, rather than perhaps the writing code for the rest of your life or developing devices, then maybe this is a good option for you. And the image here on the right is of Will, who graduated several years ago now. He was actually a capstone project student of mine, who did the Master of Engineering Biomedical with Business after having done a Biomedicine undergrad. And he is now, capital equipment manager for John Holland, a very, very big engineering company. Why are they interested in a biomedical engineer? Because it's for the Victorian Heart Hospital, okay? So, he used to be a clinical engineer at the Royal Children's Hospital. Okay, so you can see how careers can develop based on starting with your interests at undergrad and then into masters and then off into the big wide world. Okay, so let's talk a little bit about entry requirements. You do need to get into the Master of Engineering programs, be they biomedical or others, a 65% weighted average mark. And for the biomedical engineering masters, you will need to come in either via our pathways from Bachelor of Science or Biomedicine, or, okay, so you don't have to have come through one of those pathway degrees. You need to have had the 2 first-year maths, linear algebra and calculus, and then we want students that either have the depth in chemistry, biology, all right, so 2 first-year chemistries, 2 first-year biologies, or what we've recently opened up to is we want students that have done the kind of the physicsy maths side of things as well, but they may never have done chemistry or biology in their degree at all. We want those students to be able to come into our master's degree as well. And so we have this prerequisite that you could have studied engineering mathematics, and then in your master's degree, you will pick up the chemistry and biology. There's some application deadlines down there. Okay, so if you're looking for a semester 2 entry, the deadline's not until the end of April. And so, yeah, note that down if you are interested. So Bachelor of Commerce is a little bit different. And at this point, Jess, would you mind talking to this slide? Because I think you might do more justice than I do.
Yes, absolutely, Lee.
Thanks.
Thank you. So I don't know if we have any BCom students in this session today. Feel free to correct me in the chat if I'm wrong, but I will talk about it just for the sake of anyone who's watching the recording. So BCom students, they're a bit unique. They have to complete the 4 prerequisites through breadth. So in the past, there's been a limit for how many level 1 breadth subjects BCom students can study. If you've started the BCom this year, so 2022, you'll be exempt from this limit if you want to study the Masters of Biomedical Engineering. So you can complete those 4 level 1 prerequisites, the 2 maths and the 2 science. You're also exempt from that limit if you have a graduate degree package. If you're already studying the Bachelor of Commerce, so before 2022, you'll need to complete the 4th prerequisite through the Community Access Program. So that's our single subject study program. The Faculty of Engineering and IT will fund you to study that 4th prerequisite. So that means it'll be free for you so long as you've completed the 3 other prerequisites already and you have a WAM of 65 at that point. So if that's the case for you, you'll just need to obtain written approval from us, the Future Students team, to complete that last prerequisite subject at our expense. So you'll just need to contact our student recruitment coordinator, that's Monica Duggan. You can contact the Future Students team. I'd suggest contacting us anyway so we can have a discussion about your options and the best way forward for you and your situation. Yeah.
Great. Do you want to talk also to this, Jess?
Yeah, absolutely. So this is just a slide a bit about fees and funding. So for domestic pathway students, you are guaranteed a Commonwealth supported place. So that's a subsidised place as long as you meet those prerequisites and you have the 65 WAM. Other fees can be found on the website. So you can look up the Master of Biomedical Engineering program on the UniMelb website, and that has more information on the fees for international students. And then we also have the HEX Help Loan Program. That's just a bit more information that's also available to eligible CSP students. So you can defer that student contribution amount via a government loan.
Excellent. I think that might be our last slide. There we go. Questions.
Yes, that is. So if anyone has any questions for Lee, you're welcome to unmute yourself or you can pop them in the chat. We do have the chat open.
Yep. And can I just check, Jess, will you be recording the Q&A? Because sometimes people...
Yeah, I can turn it off just in case anyone is, or just